Hello, this is the video, hopefully with audio this time, for 2-1, solving equations with one variable, or excuse me, one-step equations. Well, there's still one variable, yes. Okay. Alright, so one-step equations, we're going to look at just add subtracts ones first. Basically, to solve for the variable, you perform the opposite operation on both sides. So our first problem says x plus 12 equals 23. So the middle of the problem is the equal sign. Whether it's in the exact middle or not, that's the middle. The x is plus 12. I want to know what's x. Now, a lot of you can do, well, it's 11. 11 plus 12 is 23. And I understand that, but we got to get the procedure down. Just like in English class, you can't, you have to use proper grammar and spelling and so forth. In math, there's a proper procedure for this. Okay? So it says plus 12, so if I want to solve this, I have to do the opposite. I have to subtract 12. Okay? So that cancels this side, and I get x that I can bring down. And then 23 take away 12 is 11. In the next problem, this is just a subtraction problem, but it's the same idea. I want to know what number would take away 83 and equal 24. So I add 83 to cancel it and get m by itself, and add 83, and 24 plus 83 is 107. Okay, the next problem, the only thing that makes the next problem, any more difficult is we're starting to have some negative numbers in here. So here's the equal sign, h plus 3. I'm going to subtract 3 both sides. Negative 5 take away 3 is a negative 8. Now, if in your mind the answer to that was anything besides negative 8, then please start using a calculator to type in your basic functions here. Alright, the next set, on the next row down, the order's just a little bit different. It might not have the variable first. So in this first problem, it looks like it's a plus problem, so I should subtract. Well, I'm going to end up subtracting, but not because of this plus sign. The plus sign actually goes to the w. The plus sign tells me what I'm doing to the w. So what I need to do is get w by itself. I need to cancel the 15. So I know I'm going to put 15, and I know I'm going to put 15 here. But whether I should add or subtract depends on the sign of the 15. Now, technically, there's an invisible positive sign in front of the 15. So in order to cancel that, I need to use subtraction, the opposite sign. So that would cancel, and 95 minus 15 is 80. Okay, I'll come back to the fraction one in a minute. Let's go over to this one. Okay, here's the 13, and I have to add 13 to both sides because it's a negative to start with. We want these two signs on top of each other. We want them to be opposite signs. So n is going to equal negative 1. So just to clarify, whether you should add or subtract depends on the sign that's happening to the number to begin with. You always want the signs for add subtracts to be opposites that are stacked. See how this plus n, the plus goes to the n. It makes no bearing on what I'm doing with the 13. Let's talk about the fraction. I'm not going to do anything different per se. I'm still going to add 2/3 to both sides. Whoops, I started writing that wrong. Got ahead of myself. Plus 2/3. Okay, that would cancel and the x would come down. Alright, so we got a whole number plus a fraction. That just makes 5 and 2/3. They just go together. But remember, on your calculator, you could type in 5 plus 2 and then the ABC button and then the 3 and the enter, and then your calculator knows that that's a fraction. It'll give you an answer in terms of a fraction. Okay. All right, let's talk about some multiply divide ones. So the opposite of multiply is divide. Now I see a 4, I see an x. I don't see an add, subtract, multiply, or divide sign. How do I know what I'm doing? Well, if it's a 4 next to the x, it's automatically a multiply. The opposite of multiply is divide. So I'm going to divide both sides by 4. You divide on the left-hand side to get the variable by itself, and the right-hand side gives you the answer. And notice how I'm using a division bar. We don't use the line dot dot. Line dot dot? No, we don't use that. Okay, that's just not proper. I understand what you mean. You will get the right answer, but it's like kind of like going to English class and spelling everything wrong. Your teacher can probably figure out what you meant to say, but it's not proper. So we don't use the line dot dot. Let's come back to the fraction in a minute. Negative 4x equals negative 60. Again, it's multiply, so to cancel a multiply, I divide. X equals a negative divided by a negative is a positive 15. Alright, we switch it up, and the x is on the right-hand side for this one. So it's a multiply. I cancel using division. Negative 12, because that's the number with the variable. Okay? You have to look for where the variable is. It's on the right-hand side this time with the negative 12, so that's the one that I cancel. 120 divided by negative 12 is negative 10. Okay, I'm going to do the fraction very last. All right, let's come to this bottom row. These look like fractions, but they're really not. They're division. That's a division bar, just like this was a division bar. So the opposite of divide is multiply. Now you have a couple options. You can use dots. Okay, because we're going to multiply both sides by 5. That cancels the 5 and gets m by itself. And 7 times 5 is 35. So dots are acceptable. You could also use parentheses. That's acceptable. Okay, so I multiply by negative 2 to cancel out the divide by negative 2. And you get w equals 16. You cannot use x for times when we're solving equations. You just can't, because x is a variable. You have to use dots and or parentheses. Now, students have told me kind of informally they prefer the dots. So I'll still use a mixture of both because you have to see both, but I'm hearing that dots are more popular. So cancel the 4's. Negative 10 times 4 is negative 40. Okay, let's go talk about that fraction for a minute. All right, let me get to a blank screen. Okay, if I had 30 divided by 30, we could all agree that that would be 1. Okay? And 1 times x, 1 times anything equals itself. So I could get, if I have 5/6, I want to cancel that coefficient and make a 1 so that I can get just x by itself. So when you have a fraction, you multiply by the reciprocal. A reciprocal means take the fraction and flip it over. So when you multiply by the reciprocal, that's how I'm getting 30. 6 times 5 is 30, and 5 times 6 is 30. 30 over 30 makes a 1, and 1 times x makes an x. So fractions work. That's like a long series of steps to explain why this works. And I got to be on the right flip chart here. There we go. Okay, what I want you to remember is that if you see a fraction, okay, these are not fractions down here on the bottom row. That's a fraction, a number on top, a number on the bottom, and the variable is next to it. You're going to flip the fraction upside down, and that's what you will do on both sides. And it feels unnatural because it's already a multiply problem, and I'm multiplying to solve it. So it feels unnatural. Feels like it goes against what the other problems are, but this is a special case. Okay, and then 5 times 6 is 30, and 6 times 5 is 30. Basically, these two cancel each other out. And then as far as 30 times 6/5, just type in 30 times 6, then the divide key, and 5. And you should get 36. Okay, now for the homework assignment. Okay, so here's the answers to the first 10 homeworks, basic homework problems, these 2 rows. Please remember, you can't just go in and put those in the boxes on the paper. You have to show work. Okay, so I'm showing you these so that if you do the first 10 homeworks and you find that you're getting wrong answers a lot, that would be a signal. Gee, I better go see Miss Sanders for tutoring. Okay, so show your work. Don't just write these answers, and remember your homework has a back page. All right, hopefully the audio worked on this, and have a great day. See you next time.